Good afternoon, class. Okay, so at this point we have completed couple examples, and you guys did some homework, correct? Right, the homework was on exercise 2. Okay, we're not too far yet, no? Exercise 2, page 7. Okay. Let's look at exercise 2, page 7. Any issues there? Number 3. Number 5. 3 and 5. Okay, no problem. So let's cut this. Whoops. Exercise 2, page 7, number 3. And number 5. There we go. No. Why am I cutting 6 as well? Okay, so 3 and 5. We told that the sum of the second and sixth term of an arithmetic sequence is 4. The sum of the sum of the second and sixth term. So that's going to be T2 plus T6, not so? T2 plus T6 of arithmetic sequence is 4. So T2 plus T6. T2 plus T6 is 4. The third term, T3, is 24 more than the 11th term. The third term is 24 more than the 11th. You managed to set up the equations like that. Huh? Yes, so that isn't the problem. First question says, determine the sum, the first 3 terms of the sequence. So what do we need for the first 3 terms? We need A, we need A and D. Not so? We need A and D. So, we know that the general term of arithmetic sequence is Tn is equal to A plus n minus 1d. That's a general term of arithmetic sequence. So for T2, it's going to be A plus D plus. For T6, A plus 5d is 4. So that's going to give you 2A plus 6d is equal to 4. Take that over. Divide by 2. So A is equal to negative 3d plus 2. And that's equation. On the other hand, we have T3, which is A plus 2d, equals, for T11 is A plus 10d plus 24. The A's cancels, not so? We take 2d minus 10d. What is 2d minus 10d? Negative 8d. is equal to 24. So therefore D is equal to negative 3. No simultaneous equations needed yet. Or we don't have to go with elimination or substitution with two unknowns. We already got D. Not so? So what do we still need? A. So we'll substitute this into this equation. Equation 1. So A is equal to negative 3 times negative 3 plus 2. Which is 9 plus 2 is 11. Is that correct? Okay. So my first three terms is going to be A plus D, A plus 2D, and so on. Okay? So it's going to be 11. 11 minus 3 is 8. 8 minus 3 is. So these are the first three terms of your sequence. Okay? So what was the problem here? When you did the sum?
I don't know, sir. I think I didn't know that I could just go straight into D is equal to
Negative 3.
yes, sir.
So you were expected to get an A out.
Yes, sir.
Yeah, to do simultaneous equations. From the offset, I was also thought you're going to do simultaneous equations. That's why I labeled it equation 1. But because of the equation that we set up here for T3 and T11, that is why the A's cancel out. Okay. People, what was question 3.2? Huh? The nth term. So Tn is equal to A plus n minus 1d. What's your A value? 11 plus n minus 1 times negative 3. So that's going to give you negative 3n. That's going to give you positive 3. Plus 11 is going to give you 14. Okay, any issues there? No? 3.3, determine the 17th term of the sequence. So T17, this is 3.3. So wherever I put here n, I put a 17. Okay, I'm going to put this, wherever I see a n, I'm going to put a 17. As we know, n is the position number. So it's negative 3 times 17 plus 14. Which gives us negative 37. Any issues there? The last one, is negative 72 a term of the sequence? Justify your answer. So in other words, Tn must be negative 72. So in other words, we're calculating the n value, not so. So what is Tn? Negative 3n plus 14 is equal to negative 72. Take it over the equal sign is negative 3n is equal to negative 72 minus 14 is negative 86 divided by negative 3. So therefore, n is equal to, it's going to give you 2 is 26. That is not going to simplify. Not so, it's going to remain a fraction. Correct? Right, so therefore, Tn can never be equal to negative 72. Why? Because n needs to be an element of natural numbers and not z. It is natural numbers. Okay, any confusion there? No? You should get question 5. It's also from exercise 2 on page 7. Consider sequence 13, 11, 9, 7 and 5. Determine the formula for the nth term. That shouldn't be a problem, no? So how do I move from one term to the next? I subtract 2 all the time. Not so. So in other words, Tn is equal to A plus n minus 1 d. My A value of course is 13 plus n minus 1 times negative 2. So it's negative 2n plus 15. Not so? Now in 5.2, it says show that Tn plus T15 minus n is equal to 0 for n is an element of natural numbers, which is the case normally, but n is less than 15. Okay, this is the condition that needs to be met. It has to be less than 15. Why must it be less than 15? Who can tell me why must n be less than 15? Anybody? Anybody? What if n? Yes.
Sir, because it's like 15 minus n, sir.
Here we go, yes. It's to do with this here, 15 minus n. So if n is less than 15, any number less than 15, give me any number less than 15. 14. 15 minus 14 is what? Any other number? Negative 5, no? Can it be negative 5? No, why? N has to be natural. Any number less than 15 but natural, let's use 3. 15 minus 3 is going to be 12. However, if n is more than 50, let's go 16. What's 15 minus 16? Negative 1. In other words, you got t to the negative 1 here, which can't be. Why? Because the position number has to be positive. Can't be negative. Not so? And that is the reason why you see things like this next to the sum. And n has to be natural numbers. That's why you see that. That doesn't become part of the sum and then you say plus n minus. No, that's not part. It is just a restriction that is placed on that equation. You guys understand? Okay. So this is a show that question. The show that is the same as a proof. You are required to prove. You guys understand? When you get to show that question or a proof question, you don't use the equation like it is. You break it up into a left hand, right hand side story. Okay? Learners at the end of the year lose a lot of marks on prove that and show that questions. Okay? A lot of marks. So which side is more complex? The left hand side. Okay. So if you got Tn plus T15 minus n. What is Tn? So what I'm going to do is I'm going to simplify the left hand side so much that you can get almost the right hand side, or you get the right hand side. Okay, sometimes you must work with the left hand side and the right hand side. Okay, but here if it's 0, how can you make 0 into anything other than that? So we're going to work towards 0 now. Okay, but as I said, there are times we're going to work out the left hand and the right hand side. Okay, you all okay with that? So what is Tn? What is Tn? Sorry? Minus 2n plus 15. Not so? So it's going to be minus 2n plus 15. But what is Tn? The T15 minus n equal. Remember that Tn is going to be minus 2n plus 15. What would T2 be? Negative 2 times 2 plus 15. What would Tm be? Negative 2 times m plus 15. So what would T15 minus n be? Negative 2, it will be positive. So it will be plus negative 2 into 15 minus n plus 15. You all agree with that? Any confusion? No? So what we did was, wherever we saw an n, we replaced it with 15 minus 8. Can you see that, people? You all understand? So what we do is just a matter of simplifying. So it's negative 2n plus 15 plus, we're going to multiply this inside the bracket out. So it's going to be negative 30 plus 2n plus 15. Now we just get rid of that square brackets. It's negative 2n plus 15 minus 30 plus 2n plus 15. Otherwise I could have added like terms there if you wanted to. But what do you notice now? Negative 2n plus 2n, cancel. 15 minus 30 plus 0. So what do you notice? It's going to be 0, which is also equal to the right answer. And that's the proof that will show that question. Sometimes it's normally worth 3 marks. Okay? Any confusion? No? Alright. Now we're looking at geometric sequences, and I asked you to read through the rules there that was that you dealt with in grade 11. I think we looked at geometric sequences last year, no? We're on page 8. Examples on page 8. So worked example 1 on page 8, we are but firstly, just to refresh your memory, what's a general term for geometric pattern? And when is something a geometric pattern? It has a common ratio. Okay. So the general term of a geometric pattern, A, R, n minus 1. That's a general term of a geometric pattern or sequence. What does the A stand for? First term. What does R stand for? Common ratio. What does n stand for? Position number. And what does Tn stand for? General term. Exactly as we had for arithmetic, the same for geometric provides the fact that R is going to be a common ratio, while in your arithmetic or your linear patterns, you have a D value, which is your common difference. You guys understand? Any confusion there? No. Consider the sequence 96, 48, 24, 12 and so on. The dots means it carries on following that pattern. State the value of the next 3 terms. Write down the next 3 terms in this pattern. Right, so what will the next 3 terms be? How do I move from one term to the next? You're multiplying it by half. And then, again multiplying by half. Again multiplying by half. So what will the next 3 terms be? 6, 3, 3 over 2. Okay. Some of you would say, okay, it's actually dividing by 2. Not so, which is also correct. But for your ratio, for a common ratio, is what you're multiplying it by over time. You remember ratio and proportion? It's what we multiplied it by over time. If you consider it as it being divided by, it is actually multiplying it by its reciprocal. So if you're dividing it by 2, what's the reciprocal of 2? 1 over 2. If we're dividing it by 8, what's the reciprocal of of 8? 1 over 4. You guys understand? Determine the formula for the nth term. Okay? So how do we start the formula? It's going to be Tn is equal to AR n minus 1. Right, write down the formula quickly. Right, so what's my A value? 96. What's my R value? Half. Raise to the exponent? N minus 1. Can I say that is 48 raised to the N minus 1? Can I multiply 96 and a half together? No, why not? Because of the variable exponent. Can you see this exponent here? Because of that, I can't multiply those bases. Does it make sense? Right. So you leave it as 96 into a half n minus 1. There is a way of simplifying that. Okay? But that suffices. You'll get your full marks at that point. Okay? Don't want to complicate your lives here. Okay? Let's look at number 3. In number 3, they want to know, determine the value of the 10th term. So in other words, your n is going to be 10 now. So work out the 10 for me quickly. So everybody will see n, I put a 10. So it's 96 into a half 10 minus 1, which is 9. But I've just written 9 there. And that is 96. Open brackets of close brackets raised to the exponent 10 minus 1 or 9. Can I give you 3 over 16. Are you all okay with that? Any confusion? None yet. Okay. Let's look at number 4. Which term has a value of 3 over 46? So in other words, the nth term is 346. 3 over 46. 64. Okay. So what is Tn? 96 into a half n minus 1. So you write that in. You solve for n now. Walaikum salam. Okay, so what do we get? 96 into a half n minus 1 is equal to 3 over 64. So what do I do now? Divide by 96 both sides. Not so. So it cancels. Leaves you the half n minus 1 equals. What is that going to give us an answer of? 1 over 1000 and 2048. 2040. 48. You all agree with that? So now we need to make the bases the same for the exponents to be equal. Not so? So 2048 can be written as 2 to what exponent? For those of you who forgot, you say 2048 equals shift, you press this button here. Okay? Shift is 2 to the exponent 11. So in other words, it will be 1 over 2 to the exponent 11. You can't put in this calculator 1 over 2048. It won't factorize that for you. Okay, they only factorize natural numbers. Okay? So what can we say from here? When bases are the same? When bases are the same, what can we conclude? Exponents are equal. So n minus 1 is equal to 11. So therefore n is equal to 12. Okay. Any confusion there? All right. Let's look at the example 2 on page 9. Example 2 on page 9. So here we are given x minus 6. We got 2x minus 6. 5x plus 3 are the first 3 terms of a geometric sequence. So what is exclusive to geometric sequences? Okay, what is exclusive to arithmetic sequences? Common difference. How do you work out common difference? T3 minus T2 is equal to T2 minus T1. So what is exclusive to geometric patterns? Common ratio. And what is common ratio? T3 over T2 must be equal to T2 over T1. We just go back to the previous work for geometric sequence. Let's just look here quickly. We take that sequence into account. See here. That's T1, T2, T3. You see that? That's going to be T3 over T2. Let's see what is that? 24 over 48, which is half. Can you see that? We've got T2 over T1. It's going to give you 48 over 96, which is also half. Can you see that? So in other words, T3 over T2 must be equal to T2 over T1, which is your R value. That's your common ratio. Does it make sense? Okay, so that is what is exclusive to geometric patterns only. Okay, so if you didn't know that, please highlight this. It's very important. The common ratio. Common ratio is going to be T3 divided by T2 is equal to T2 over T1. So x minus 6, 2x minus 6, 5x plus 3 are the first 3 terms of a geometric sequence. The question says solve for x, showing all the necessary calculations. So where do we start? We start off by saying the ratio is going to be T3 over T2 must be equal to T2 over T1. Remember, this is term 1, term 2, term 3. Guys understand? Now you do the substitution, you don't need the R here, you can drop the R. And then you solve for x for me, okay? Can you guys do that? Yes. Is that how you guys feel when you hear the maths homework? Tired, huh? No, man. What's wrong with you guys? Right, you guys ready? Right, so for T3, it's going to be, what is T3? 5x plus 3 over 2x minus 6 equals 2x minus 6 over x minus 6. So what do I do now? Cross multiply. So it's 2x minus 6 times 2x minus 6, it's 2x minus 6 squared. So it's going to be 4x squared. Minus 12 is minus 24x plus 36 equals 5x squared. 3x minus 30 is going to be negative 27x minus 18. Is that correct? Don't know yet, okay? Take everything to one side, because that's trinomial, so 0 is equal to 5x squared minus 4x squared is going to give you x squared. Negative 27x plus 24x is negative 3x. Negative 18 minus 56 is negative 54. Is that correct? Did I make a mistake? Is that right? Yes. So what do we do? Trinomial. If you don't know how to factorize a trinomial, use the quadratic formula. Do not keep yourself brave and factorizing. Okay? Everybody knows how to use the quadratic formula here. Not so? So use the quadratic formula. Okay. So what do we get here? Oh, if you got the silver calculator, you can make use of the factorizing option there. Or your roots. It's going to give you 9 and negative 6. So x equal to 9 or x equal to negative 6. Okay. How is my 6 upside down? Okay. Any confusion here? No? You got the silver calculator? Then you get one like this? The white one, silver one? This is the one with that option. You know how to use it. Press mode. Oops. Not with the red pin. Press mode. You see 5 is equation. This 5. Now, that equation that we're factorizing is a quadratic equation. So it's number 3. Later on, we're going to use number 4 for cubics. So it's 3 for now. Right? Now, that there is for the formula in this form. Ax squared plus bx plus c. So, the coefficient of a is 1. So, you press 1 equals. The b is negative 3. Can you see it? So negative 3 equals, so it's 1 equal, negative 3 equal, negative 54 equal again, you get 9 and negative 6. Okay. Are you all okay with this here so far? Alright. Let's look at number 2. Number 2 says if x is equal to negative 6. If x is equal to negative 6. So which now confirms what I have here. Not so. It confirms what I have here. State the first 3 terms of the sequence and the nth term of the sequence. So the first term is x minus 6, 2x minus 6, and 5x plus 3. So if x is equal to negative 6, then what is it? Minus 6 is negative 12. Not so? 2 times negative 6, negative 12 minus 6, negative 18. 5 times negative 6, negative 30. Negative 30 plus 3, negative 26. These are my first 3 terms of the sequence. Okay? Any confusion here? Now you work out the general term of the sequence quickly. Okay, so what do we get? My A value is negative 12. R is 3 over 2. Is that correct? 3 over 2 raised to the exponent n minus 1.
So,
Yes.
how do you work out all
So it will be T2 over T1. Put there negative 18 divided by negative 12. But you confirm it by saying negative 27. Put there negative 27 over negative 18. Here with 2. Can you see that? You just confirm it. You can't just do it with 1. So it could be arithmetic. And how do we confirm it? By doing what we just did now. Okay. Let's look at number 3. In number 3 they said if x is equal to 9. So if x is equal to 9, what's the first term? 9 minus 6. What's 9 minus 6? 3. What's 2 times 9 minus 6? Huh? 12. 5 times 9 plus 3 is 45. 40. Now you work out the general term. Okay, so we get A, R, n minus 1. My A value is 3. R is, how do we move from one term to the next? Multiplied by 4. So it's 4, n minus 1. Okay, any confusion here? You guys understand? Who's confused? Nobody, okay. So your homework is going to be exercise 3. It's exactly what we did now, okay? Now we're looking at example 1 on page 10. Example 1 on page 10. Example 1, page 10. Here we are told the second term in a geometric sequence is negative 4. So what do you think we're going to write here? T2 equals negative 4. So write that down. And the fifth term is 32. The fifth term is 32. So what do you write there? T? 5, yes? Is going to be 32. So write that. But remember they told us it is the second term in a geometric pattern. So what does that mean? If it says geometric, we can only use geometric formulas. Not so. If it had said the second term of an arithmetic progression is negative 4 and the fifth term is 32, then I can only use arithmetic formula. Make sense? But since it says geometric, you can only use geometric formula. Okay? Are you all okay with that? So we're saying that T we are saying that T2 is negative 4 and T5 is 32. But what's a general formula, a general term formula for geometric patterns? What is that? Tn is equal to A R n minus 1. That's all. A R n minus 1. So if you're looking at T2, what would T2 then be? T2 is going to be A R 2 minus 1, which is 1. What would term 5 be? A or 5 minus 1. And 5 minus 1 is 4. Not so. So write each one there as follows. It's going to be A R is equal to negative 4. Make A the subject of the formula. It's negative 4 over R. It's equation 1. Now you do the same for equation for the second formula. T5 is equal to 32. And you get equation 2 out. And then what would it go into, people? Simultaneous equations. So do that quickly. And I'm going to show you afterwards another method that you could apply the same thing. It will be the method that I'm adopting, okay? For this work specifically. You guys got it? Got it? So busy? We're still busy with the sum? Just with number 1, eh? Not worrying about number 2. Still with number 1. Okay. So this would simply be AR 4 equals 32. Not so. This is equation 2. So to do our simultaneous equations, we're going to substitute equation 1 wherever we see A in equation 2. So that would simply be negative 4 over R times R4 equals 32. You all agree with that? So what can happen now? R's cancel. I'll give you R cubed. So it's negative 4R cubed equals 32. Now what? What do you do now? Divide by negative 4 both sides. So that cancels. So R cubed is equal to negative 8. How do I get R on its own? Get R on its own? Cube root both sides. So therefore R is equal to negative. Have I answered the question? Determine the formula, so I still need R. Not so? I mean still A. So what we do is we can substitute that into that equation. So therefore A is equal to negative 4 over R, which is negative 2, which is 2. So therefore Tn is equal to A R n minus 1. So it's 2 into R, which is negative 2 n minus 1. So there's my formula that you can find. Okay. Of course, there was another way of doing it. I would say it's probably easier, a bit easier. Take it at that point there. So for T2, it's going to be, you don't even need to write like this. Because we're busy with the ratios, I can put term 5 over term 2 is equal to. So what is term 5 equal to? Okay, it's 32 over negative 4, which is also equal to. What is T5 equal to? A, in terms of the formula, A R 4 over A R. Not so. So what I do is the A's cancel. Okay? R cancels with one of the 3 R's. One of the 4 R's, sorry. So in other words, I have R cubed, 32 divided by negative 4, negative 8. So much easier, not so? How do I get R on its own? Cube root both sides. So R is equal to negative 2. What we do is we just substitute that into any one of the 2, smaller one normally. So it's going to be A, R, it's coming straight from here, people. T2, and here. So that would be A, R is negative 2 equals negative 4. Divide by negative 2 both sides. So A is equal to. We answer the question. The question says determine Tn. So therefore Tn is equal to AR n minus 1. You don't need to write the formula down again. So it's 2, R is negative 2, n minus 1. Okay. People, the next question. Number 2. Which term has a value of negative 1024? So what do I do with that? I say Tn is equal to negative 1024. What is the value? What is Tn? 2 into negative 2, n minus 1 is equal to negative 1024. Now what? Now what do we do? Divide it by 2 both sides. So it's negative 2 raised to the exponent, n minus 1 is equal to negative 512. Now what? Now what do we do? When bases are the same, exponents are equal. So we got negative 2 raised to the n minus 1 is equal to negative 2 to some exponent. What exponent would that be? Firstly, it has to be an odd exponent.
Attention please. Following learners, can you please report to the office?
What's it?
Medina Rubigana, Saskia Doman, Tamika
So therefore,
Swapoi, Melissa Pelingani,
n
and
minus 1 is equal
Jonathan
to?
Moses.
So
As
therefore,
well
n is
as
equal
Lisa
to?
Kanya Makiva. Lisa Kanya Makiva.
And the last question before we leave, another bell rang. It says determine the 8th term of the sequence. That's simple. T8 is equal to? My general
All
term?
tennis learners who took part in tennis last year, there is tennis practice
Two.
tomorrow because there's a match
8
coming
minus
up.
1.
Can you please report for your tennis practice tomorrow?
There's two.
And please be on time. Thank you.
Okay, we're going to get a calculator in the form again, in the right form. So shift 9, 3, or you could have pressed mode and 1. Okay, so 2 open brackets negative 2 to the exponent 7 gives you negative 256. Okay, any confusion here, people? Right, for homework. Tomorrow we will do the work example 2. So you should be able to answer the following. Exercise 4 on page 11. You should be able to answer question 1, 2, and 5. 1, 2, and 5. Add that to your homework. People, enjoy the rest of your day. Good afternoon, class.